Okay, so I'm going to open the packet tracer, and meanwhile let's understand the lab, what we're going to do. So we're going to do the lab for DNS lab, and let me open them. Okay, so you are able to see my screen, right?
Yes.
Okay, DNS. In DNS, so today we will see in lab, we will do the lab and we will understand on packet level. So what port number? Is this TCP port number or UDP port number? DNS use the 53 port number, which port number? By doing the packet analysis, we're going to see. Okay. Now,
Okay.
which layer of protocol this? This is network layer of protocol or this is application? We will do lab and we will understand which layer of protocol. As we know, this is a layer 7 protocol, right? This is
Yeah.
layer 7 protocol. It's not a network layer protocol. And we will see the what do you mean by a record. Let's brief it. What is a record? A means it's not this. A is stand for the address. This address is specific to IPv4. IPv4 address means IPv4 record. Okay, address record. This is Nslookup record means a record going to maintain the IP address with their name, means by which name it's going to be mapped. So actual mapping going to be happened in a record. Clear?
Yes.
Then you can ask me, Astus, okay, for IPv4 this, but everywhere we can see IPv6. So what about IPv6 record? So IPv6 record is called a not triple A, is a 4-time A record. Okay, they have dual stack. They're going to capture that. Now, come to the before going NS record. Let's understand the name server. Name server is nothing. It's called DNS, domain name server. Means name server is going to maintain name with the IP, and the domain name server is the same. It's specific to domain. Of course, without domain there is nothing. So every domain having their name server. So DNS is called name server. Clear? Now come to NS record. This is a name server record. Means NS record not going to resolve your IP into the name or name into the IP. A record going to do that, but NS record going to maintain the list of DNS server. Maintain the list of DNS server. DNS server 1, DNS server 2, DNS server 3, DNS server 4. Okay. Every DNS server having a record. They create a record. Okay, every DNS server. So NS record going to tell you for the specific name who will be the authority, who has authoritative DNS, who going to answer you, which DNS server having your answer. Clear?
Yes.
So NS record is different from a record. NS record tell you who going to answer, who going to answer your query. So which is the authoritative DNS server authorized to give you answer. So maybe you are looking for something, you ping for cisco.com. So they have, maybe the primary is the DNS1. They have answer for this. So NS record going to redirect you DNS1. Suppose you are asking hp.com and this record is maintained here DNS4, so they're going to NS record redirect to the DNS. Clear, guys?
Yes.
Okay, come to the NS lookup. NS lookup going to, you know that this is the end user app who's going to help you application or the command line UI interface command, user interface command, which is going to help you get the proper three things. What you going to get by NS lookup? NS lookup you going to get the who is my DNS, who is my authoritative DNS, means a record, where is the a record is captured. Okay, a record is captured, where is the a record. Okay, someone telling this is 8.8.8 is a what global DNS, is it true? It's a global NS record they maintain. He going to redirect you who is the authoritative DNS who going to answer your question. Clear, Sagar?
We- Can
Okay.
you repeat this? I'm still not clear to me.
Okay, so if you know the global DNS is 8.8.8, right?
Yes.
Yes. So this is this they maintain the NS record. They did not maintain the A record.
Okay.
What do you mean by that? Suppose you uh, um, going to download the packet tracer from Cisco website, right? So he once you click this, they will give you one website and they will follow the cisco.com, and inside that so many domain name. So this global DNS, they don't know about that. They never keep entry because that's a Cisco proprietary. But he now who will give you answer in Cisco? So they have entry of Cisco DNS.
Okay.
Clear. So NS record, they redirect your packet to the who, and that Cisco DNS having the all a record. Otherwise it's going to be no use because all they're going to be public, they're going to know about that. So they can redirect your right name server. Okay, now NS lookup going to give you the DNS name on which the record is maintained. Okay, and the what name with the what IP, and by default is the dual stack, so they will give you maintain with the a record and as well as a record also, so they will give you IPv6 address. Clear? Now last not least, this is the command by which you can enable the DNS lookup in switch and router. Clear?
Okay.
Yes. So by looking network IP address, by on the networking side, we're going to run the DNS, enable the DNS on routing switching using this command. Let's do the quickly lab on this, and we will good to close the today's session. You can go on mute. I think there is a lots of sound coming. Okay. So come to the packet tracer. We are on packet tracer, so we can select this is a small lab, so we will select one DNS server first. This is a DNS server. Second, I will select one switch. Go to switch. I will take 3560 and let's select some PC. So we will select PC and we will check it how it's going to work. And I will take one more server, so that HTTP, that day we saw we are using the HTTP using the IP address, HTTP with the IP name, but today we will use the domain name, not the IP name, and we will test that. So now select cable connect to the switch, and quickly we can set up our lab. Okay, so I'm going to name it, this is my DNS server, and I'm going to name it this is my wave server. Okay, wave server, and this is the PC from where we're going to, okay, PC 0, that's okay. So I'm going to give IP over here. So what will be the IP? Let's assign the IP here, 192.168.1.11 IP. I'm going to give this PC. Now next I have 192.168.1.111 for the wave server, and 192.168.1.1110 for the DNS server. Clear? And these are the IP. That's you clear that. Okay. So let's start. Let's assign the IP address. Are you able to see? Hello?
Yes, able to see.
Okay, so let's close this. Should not hang. Let me save this and save as in DNS and close this. You want to save? Yes. And let me open again. It's look like it's hanging. Packet tracer, opening this. Open the same DNS. Okay. Yes. Hang on. It's working. Now come to the desktop. Give IP address. So what IP we have? 11. So I'm giving 192.168.1.11. This is the subnet marks, and I will check IP config. Come to the DNS, and I'm going to assign the DNS the IP 192.168.1.110. Clear? And same way we will assign the IP for the server, wave server, 192.168.1.341. Okay, now let's test it. I'm able to ping all these IP 192.168.1.11. this is my IP, and go to 111. This is a wave server, and last one 11110. This is for my DNS server. So for PC, I'm going to define the DNS name. Well, can you see the DNS server name, Sagar?
Yes.
So I should define my DNS name as a 192.168.1.1110. Okay, this is my DNS, and I will check this DNS is applicable here when I will check for IP config. So DNS coming here. No, that's not giving. Let me check if /all if I will do. So DNS name, yes, can you see this is DNS server name here, DNS server name. Okay, so DNS name is came and DNS is pingable from our PC. Same way we will test from here. I will configure the DNS name as 192.168.1.110 and we will check here my DNS name and resolution supposed to be have DNS all. So we have DNS server name right, and I'm able to ping that 192.168.1. So networking part is completed now. So we have to check whether I'm able to resolve the name or not. So this PC name, just I'm giving this PC name, changing this PC name as a John. Okay, as a John. And this wave server, like I'm giving this wave server as a cisco.com. Cisco.com. Clear?
Yes.
Okay. Now, if I'm able to ping this cisco.com or not, let's see. Pinging cisco.com. Okay, or www.cisco.com, anything. www.cisco.com. This is not pingable. Okay, because there is no DNS entry for this. You can go on mute. And if I will ping John, that also not pingable because there is no entry in DNS server. We have given name, this not matter. It network don't know, means DNS server should know. We have to create a record, that is called a record. So let's create the a record. So I will go to service and click the DNS. Can you see this DNS? Once I will click DNS, can you see a record, CNAME, NS record. Okay, so here we have only one DNS server, so that's going to be NS record. So I'm not going to do NS record. If you have multiple server, then only NS record going to be maintained by the one centralized DNS, right? So I'm going for the a record. So my John going to be the name and the what going to be IP 192.168.1.11 going to be, and add this. So we have a record, type is a record, detail is IP, this name is John, and second we have www.cisco.com and the IP will be 192.168.1.111, right? And we can add one more by other name. Suppose someone typing only cisco.com, let's add this also. So you any name they're going to take out of these two, they will come to the same IP. Clear? And we're going to switch on my DNS. Clear?
Yes.
Yes. So let's test by yourself. You are able to ping yourself or not. So I'm pinging John from myself. I'm pinging myself. Can you see they're going to resolve with this IP? Earlier it was not resolving, right? Earlier it was not resolving. Come to here. Earlier this, if I will ping John, so they're going to do the DNS lookup. They are able to ping. Let's see how the packet are moving. So I'm going to on the simulator, okay, and we're going to check what going to happen once the ping will start from here for John. So come to here. So we have DNS lookup. Can you see here? Go to next. Now packet reach to switch. For this is cisco.com. From cisco.com they are taking, but we ping to, then DNS solution they took. They need to go here, but they went to the first DNS. Are you able to see? Are you able to see?
Yes.
And we can open and see the packet, what going to happen to the packet. So now the packet came here. So I want to check this. What is the packet? Multi-layer switch. Multi-layer switch, we have IP address ICMP reached. Before that, before ICMP, we have DNS lookup. So let's check for DNS lookup. I'm interested in checking in DNS lookup. I will come to this and we'll check this packet. So I can see the packet form. The packet is from DNS Cisco. Yes, I want to see this. The first packet says that the source port they taken random anything, and destination packet, can you see destination packet here? Destination packet 53. Are you able to see? So this 53 is a UDP packet. So always DNS work on UDP 53. And the layer 7, this is the application layer. This is the application layer, this is not. Now this is the request generated from the, and now if you go for DNS, this one multi-layer switch, if you want to see what happened here, the reply just source is a 53, means this reply coming from the DNS. This reply coming from the DNS reply with the application layer, source port 53 and the highest destination. This is the reply packet. And reply goes to whom? The destination is this, because web server want to know who is the John. So he given the reply to the John. Clear? Now.
Yes.
And let's see the packet, the pinging completed. Now we will do the testing. We will stop this simulator, and now we will do the testing for the from here website. Earlier what we have done, we have given the 192.168 by IP, we used this, right? But I don't want to using IP because no one remember the web. While you going to access the web browser, you are not going to use the IP, you're going to use the domain name. So just I want to ping www.cisco.com. okay, so we are going to reach here. So if you see this going to first packet reach to the DNS server, it's resolved, then it's went to the, so let's check it out. I'm going to stop this. I'm going to create new web and we'll start simulation, and this is cisco.com only I will. So let's see what happened to packet generated from the PC. Let's start from here. Packet generated from PC with the application layer DNS, source as any higher value than 1024, destination is a 53, that's a UDP packet. So DNS generate packet for the UDP, not TCP. And the source, who is the source? Source is the .11, my PC, and destination is my DNS server, not my web server, So this request to the DNS. Now once he will receive the DNS, he received the DNS. If you see DNS received by the John, let's see what he received. So he received the packet DNS application layer, source as a 53, means DNS reply. Who is the source? 110, means 53 port. Who going to reply? Server going to use the 53 port to reply. And to whom? To PC on the same port which he initiated. Clear?
Yes.
Yeah. So this is good. And come to the, now if you go for higher, once he DNS is completed, he got, now he started the TCP, no more UDP. Means if you see first packet, what the no, not this packet. I want to show you this first packet by the John for the HTTP. So layer 2 multi-layer switch, John multi-layer. I want to see to the server, wave server. Where is the wave server? Yes, cisco.com. Here, this also layer 2 packet TCP. This HTTP. I want to see the layer. Yes, this is the layer 7. Layer 7 packet TCP 80 packet. So this is client side, which going to be the client side is going to be happen, means this source is the server, TCP server, means post 80 HTTP server. Clear? Okay, so by this, any question you want to ask, and we will do next class for subnetting, and we'll see next topic. It's going to be cover boot sequencing. What are the um, boot sequence? We have bootstrap, and we will see the lab, different type of lab like HTTP, sorry, how to get the code from the TFTP server, and how you have to upgrade, iOS upgrade, and what are the memory, flash, RAM, and VRAM, and other part. Okay, so I will see you in next class.